there, welcome to the Information and Knowledge Management tutorial video. The previous session highlighted the concept of knowledge management as well as the relationship between intellectual capital and knowledge assets. And now we are looking at the types of knowledge management systems for decision making, and very briefly we will touch on the subject of securing this knowledge system. But first let us understand how data is organized in a database. Data are the principal resources of an organization. Data stored in computer systems form a hierarchy extending from a single bit to a database, the major record-keeping entity of a firm. Each higher rung of this hierarchy is organized from the components below it. Data are logically organized into bits or characters, fields, records, files, and databases. A bit or a character is the smallest unit of data representation. That is, the value of a bit may be a 0 or a 1. 8 bits make a byte, which can represent a character or a special symbol in a character code. A field consists of a grouping of characters. A data field represents an attribute, that is, a characteristic or quality of some entity that can be an object, person, place, or event. A record represents a collection of attributes that describe a real-world entity. A record consists of fields, with each field describing an attribute of the entity. A file is a group of related records. Files are frequently classified by the application for which they are primarily used. Example is an employee file. A primary key in a file is the field or fields whose value identifies a record among others in a data file. A database is an integrated collection of logically related records or files. A database consolidates records previously stored in separate files into a common pool of data records that provides data for many applications. The data is managed by system software called Database Management Systems, or DBMS. The data stored in a database is independent of the application programs using it and of the types of secondary storage devices on which it is stored. Corporations and businesses go to great lengths to collect and store information about their suppliers and customers. What they haven't done a good job of in the past is fully utilizing the data to take advantage of new products or markets. The following methods have been used to assist corporations in fully utilizing collected data and information. Data warehouse. As organizations want and need more information about their company, their products, and their customers, the concept of data warehousing has become very popular. These are huge computer files that store old and new data about anything and everything that a company wants to maintain information on. Data marts. Since the data warehouse can be cumbersome because of its size and sheer volume of data, a company can break the information into smaller groups called data marts. It is easier and cheaper to sort through data marts that tend to be more focused on a particular subject. Business intelligence. Businesses collect millions of pieces of data. Using the right tools, a business can use its data to develop effective competitive strategies. Rather than guessing about which products or services are your best sellers, business intelligence provides concrete methods of analyzing exactly what customers want and how best to supply them. Online Analytical Processing, or OLAP, is the technology behind many business intelligence applications. OLAP is a powerful technology for data discovery, including capabilities for limitless report viewing, complex analytical calculations, and predictive what-if scenario for budget or forecast planning. Data mining is a practice of searching through large amounts of computerized data to find useful patterns or trends. There is no one single information system that will satisfy all the needs of an organization. At first glance, it can be difficult to comprehend all the different systems in a business, and even more difficult to understand how they relate to one another. Delivering IT services and systems to a business entails multiple levels of delivery, as can be seen from the diagram. Delivery starts from the infrastructure level of hardware and software components. As the pyramid tapers towards the top end of the MIS model, the systems and services become more focused. The operational level of an organization includes various units such as order processing, material movement control, payroll, accounts payable, and employee record keeping. This level is responsible for daily operations. The information systems used in this level of the organization are transaction processing systems, so called because they record the routine transactions that take place in everyday operations. Office automation refers to the varied computer machinery and software used to digitally create, collect, store, manipulate, and relay office information needed for accomplishing basic tasks. A management information system is a computerized database of financial information organized and programmed in such a way that it produces regular reports on operations for every level of management in a company. A decision support system is a computer-based information system that supports business or organizational decision-making activities. An executive support system is software that allows users to transform enterprise data into quickly accessible and executive-level reports, such as those used by billing, accounting, and staffing departments. An ESS enhances decision-making for executives. ESS is also known as Executive Information System. We will now look at how organizations and information systems work together, or sometimes against each other. The idea, of course, is to keep them in sync. But that is not always possible. We will look at the nature of organizations and how they relate to information systems. Firstly, how can an organization use information systems to achieve competitive advantage in the market? Porter's competitive forces model contends that much of the success or failure of a business depends on its ability to respond to its external environment. The diagram shows 4 external forces that every business must contend with at one time or another. It is important to understand from this model that a firm's success is not predicted on how well it does internally. The 5 forces need to be adhered to. Traditional competitors, always nipping at your heels with new products and services, trying to steal your customers. Digitalization has fueled the rivalry among competitors. Competitors have the ability to respond promptly to your organization's strategic actions. New market entrants, not constrained by traditional ways of producing goods and services. They can easily jump into your market and lure customers away with cheaper or better products and services. Digital business is increasingly lowering the barriers to entry. This is because it is cheaper to start up a digital business and also easy to market it through channels like social media. Substitute products and services. Customers may be willing to try substitute products and services if they decide your price is too high or the quality of your products and services is too low. Information systems may promote the development of substitute products. With the rise of the internet and globalization, new products and services are constantly being developed because of the low switching costs. Customers are now armed with new information resources that make it easier for them to jump to your competitors, new market entrants, or substitute products. Because of digitalization and the availability of information readily, customers demand that an organization constantly improves its processes, products, and services. Suppliers. The number of suppliers used may determine how easy or difficult your business will have in controlling your supply chain. Too few suppliers and you lose a lot of control. Just like any organization, suppliers also try to lock in its customers. The bargaining power of suppliers is strongest in a specialized industry where a firm has a limited choice of suppliers. The internet, especially the World Wide Web, is beginning to have an important impact on the relationships between firms and external entities, and even on the organization of business processes inside a firm. The internet increases the accessibility, storage, and distribution of information and knowledge for organizations. In essence, the internet is capable of dramatically lowering the transaction and agency costs facing most organizations. Businesses are rapidly rebuilding some of their key business processes based on the internet technology and making this technology a key component of their IT infrastructures. If prior networking is any guide, one result will be simpler business processes, fewer employees, and much flatter organizations than in the past. This table summarizes the impact the internet is having in many industries. The internet does provide new opportunities for companies to increase their customers and markets while reducing their costs. Companies like Google, Amazon, and eBay are continually creating new products and services through the internet. They are successful because they use their strategic competitive forces together with information systems to continually improve their competitive advantage. To build good quality information systems, you need to fully understand the essentials of the software development lifecycle, or SDLC. Customers' requirements to the delivered product, as well as customers' budgets. There is a number of lifecycle model types. Example, your waterfall model, spiral model, rapid prototyping, etc. Selection of a particular type of lifecycle model depends largely on your project scope and stakes. The arrow in the diagram goes only in one direction. Remember that just because you apparently completed one step doesn't mean you can never go back to it at some point in the development process. In fact, many of the steps should be revisited several times, especially if you are using the prototype method of development. Let's briefly look at each phase. Systems analysis. At this phase, it is important to document all requirements to the desired software. You should dedicate sufficient time to this phase, conducting extensive interviews with stakeholders. It is better to structure all incoming data, analyze them, consider all technical limitations that may arise on the client side, and come out with a ready-to-follow specification to meet the client's needs. Another thing to consider is any constraints that may hinder the development process, such as client's time and budget constraints. Systems design. The next step in the life cycle involves creation of a project scope document with hand-drawn sketches and a detailed software development specification. Systems design is the process of defining the architecture, components, modules, interfaces, and data for a system to satisfy specified requirements. Systems design could be seen as the application of systems theory to product development. Programming. The actual programming phase will, in all likelihood, be carried out by the IT department. If you are using a fourth-generation language, the programming could very well be done by the end user. Either way, make sure that the programming supports the analysis and design phases. If not, go back and work through them again. It could very well be that what was designed simply can't be programmed. The usual impulse is to program around the design. Do not. Redesign instead. Testing. During this phase, the system is tested for flaws and bugs. People assume that because something was designed and programmed according to the specifications in the analysis stage, it is right. This is not so. The system should be thoroughly tested by different people. Conversion. This phase involves converting the old system to the new system. Production and maintenance. After you install the new system and it is in production, You want to go back one more time and make sure it is meeting your needs through a post-implementation audit. Eventually, you're going to have to perform maintenance on the system no matter how well you design and build it. Now that the knowledge management system is up and running in your organization, how do we secure it? Let's look at what we need to secure the system from. Information systems are vulnerable to technical, organizational, and environmental threats from internal and external sources. The weakest link in the chain is poor system management. If managers at all levels don't make security and reliability their number one priority, then the threats to an information system can easily become real. The diagram gives you an idea of some of the threats to each component of a typical network. In today's business environment, it is not enough to protect hardware and software physically located within an organization. Mobile computing devices like smartphones, cell phones, netbooks, and laptops add to the vulnerability of information systems. How do you help prevent some of the problems mentioned previously? One of the best ways is to institute controls into your information system, the same way you might in any other system, through methods, policies, and procedures. Information systems control involves access controls to the physical equipment, example, your software and hardware, and the actual applications used for input, processing, and output. Risk assessment. Use risk assessment to set up cost comparisons for developing and maintaining security against the loss potential. It is done all the time in other systems, so use it for your information system as well. Because of the increasing liability for security breaches, many companies are now establishing a Chief Security Officer position to help ensure the firm maximizes the protection of information resources. Floods, fires, hurricanes, even tsunamis happen without a moment's notice. Perhaps the most important element of a successful system is a disaster recovery plan. It is important that managers and employees work with information system technicians to develop these plans. Information is as an important resource as any other in the organization. Management information system audits verify that the system was developed according to specifications, that the input, processing, and output systems are operating according to requirements, and that the data is protected against theft, abuse, and misuse. How can an organization protect itself? Access control is any mechanism by which a system grants or revokes the right to access some data or perform some action. Normally, a user must first log in to a system using some authentication system. A firewall is a network security system, either hardware or software based, that controls incoming and outgoing network traffic based on a set of rules. Intrusion detection system is a network security technology originally built for detecting vulnerability exploits against a target application or computer. Antivirus software is a program or set of programs that are designed to prevent, search for, detect, and remove software viruses and other malicious software like your worms, trojans, adware, and more. During these video tutorials, you have gained a basic understanding of knowledge management and intellectual capital. Hopefully, you have gained an appreciation for the strategic and cultural facets of the topic. Finally, you have learned about innovation as the final and paramount task of a knowledge managing manager. This alignment is critical for successful implementation of a knowledge management system. A balance between human-oriented knowledge management and technology-oriented knowledge management is also critical for a knowledge management system. And that rounds up this video. Hopefully you found this video tutorial informative. Till then, Goodbye.